I promised you that we would inspect this part that we made last week. We had a 600 thou diameter on this side, a 500 thou diameter on this side. Both of those shoulders are 1 inch. And then we had a 130 thou chamfer on this side and a 200 thou chamfer on this side. So if we start out with using a micrometer, get the easy one done, that's just measuring these diameters. And if I look at this, I am about 1.5 thou undersized on this side. Maybe 1 thou and, yeah, I'm reading 1.5 thou on the 1/2 inch side. And if I go to the 600 thou side, I'm about 1 thou undersized. So I came close, and frankly, using dial calipers, I'm pretty happy with that. To be about 1 thou off, I'll take that for using somebody else's dial calipers. Now, when we were at the lathe, we measured these shoulders with dial calipers and using the depth measurement or using the shoulder measurement on the dial calipers. I'm going to show you a much more accurate way to do it. What this is a height gauge, and it has a dial test indicator on the end of it, and we're going to use this V block, and we're going to use the height gauge to measure the difference between these two heights right here. Just back this up a little bit. The purpose of the V blocks is to make sure that this is perfectly vertical. Now, it's not perfectly vertical. We're referencing off of a non-machined surface here, and there's nothing perfect in machining. But we want it as vertical as possible so we're not getting any cosine error when we're measuring this. And the way we're going to do it is we're going to raise this height gauge all the way to the top, and we're going to come around here, and then we're going to drop it down, and we're going to lower it while the tip of the dial test indicator comes all the way around here and touches that 0. Now this is okay, back up, come at it again. This dial test indicator is a 10th reading dial test indicator. Every division on this indicator is 1/10,000th of an inch. So it is very difficult to get it perfectly lined up on the 0. But there we are. So we have that at 0, and now I'm going to 0 my height gauge. I'll show you that in just a second. So we can pivot this around here, and you'll see that this dial counts up, this counts down, and it's counting revolutions of this dial here. So we're at 0 here, 0 here, and 0 here. There's lots of different styles of height gauges. This is how mine works, and this is fairly common. So now what we can do is we can lower this down and 0 the height gauge, or 0 the dial test indicator on the shoulder. So we're going to come down, drop it right onto that shoulder, do our best to get it lined up with that 0. Maybe 1/10 off. Too far. I'll take it. And if we look at our height gauge, 1 inch pointed right at the 0. So we have a very precise 1 inch shoulder on that side. Let's go ahead and try the other side. Zero our dial test indicator once again. I'll take that. Then we can drop it down onto the shoulder once again. Okay, so we're zeroed there. And if we come around and look at this, we have 1 inch there. We're just about on the 0 there, so I will take that. Okay, so now we have measured the diameters. We were a little over a thou off. The shoulders, as far as 1 inch length, pretty much dead on. Now we have to measure the chamfers. The chamfer is probably the most difficult feature to measure on this. You could use calipers like we did at the lathe, but to get more accurate, you either need a specialized tool. We could sort of do it with this height gauge here, but I'm going to show you kind of a trick way to do it. In the shop, I would probably do it with an optical comparator. What an optical comparator does is it shines a light, a very precise light oriented from right behind, projects it onto a screen, magnifies it by 40 to 100 times, and then we could measure this here. I'm going to use basically a digital version of that. So give me a second here to get that set up. What I have set up here is a digital microscope, and it's using software called Dino Capture. The software is made by the maker of the microscope, Lathe. One of the nice features of this is once you get it calibrated, it remembers its zoom. So you can zoom in and out and still take measurements. It allows you to take measurements in real time. So if we put our part in here, and you can see that I'm actually looking at the part. Oops. There we go. And then I can use these tools up here to measure the chamfer on the part. So for example, I am going to use a 0.2 line tool right here. And then I can come down here. And I can create a line for the face of my part and then drag a line out here. And there we go. And then I can do the same thing for the other side. So there we go. That is the inspection of our part. We used the micrometer to get the two diameters, and we figured we were better than 1.5 thou on either of the two diameters. We were pretty much dead on our 1 inch, which we would expect because we used the DRO to do these two shoulders. And then our chamfers came out pretty much dead on too, which was due to care in how we did it through the machining process. Thanks for tuning in. Stay safe and have fun.